Hey everyone, so in this video we are going to make a 3D voxel world with destructible blocks similar to a game like Minecraft. Now, this is obviously going to be much more small scale than Minecraft, but this is going to get you started and then you'll be able to, at a certain point take it from there and work on it on your own. But we're going to show you how to create the 3D world, how to make the blocks destructible, and then in later videos, we'll add like player movement and maybe tools and weapons, that kind of thing. So this one's really just making the world and making it be destructible. So the only prep work that you need ahead of time is you need to make the blocks, and you can make these in whatever application you want. So I made these in Magica Voxel. Magica Voxel is a free-to-use 3D modeler. You can download it right now from GitHub if you wish to use that. I already posted tutorials about how to draw the blocks in Magica Voxel. If you don't want to use a third-party application and you just want to stick with Unity, you can use Pro Builder. To install Pro Builder, you go to Window, you go to Package Manager. Once this loads, there's Pro Builder. You'll have an install button. Click on Install. And then once you do, you then have the Tools menu and Pro Builder. Not going to go into Pro Builder here because that too I already posted a tutorial for. But it's pretty straightforward to make a block and paint it. So once you have your blocks, and those are just two methods, you can use whatever application you want. We now need to take those models and turn them into prefabs. So let's start with our grass block here. And you can see it just looks like what you typically think of as a grass block. Okay. For whatever reason, Unity insists on adding this parent, and I don't know why. It's this essentially an empty object. So we're just going to unpack this. In other words, we're going to break this away from that. So we're going to do unpack prefab, then you just grab the default and that separates it, and then we delete that unwanted parent. I think in all the projects I've worked on, I can only think of one use case where I'd actually want that extra parent created by default. So now we want to rename this, and we're going to have it match the model name. So it's going to be block grass 00. Now we need to add a few components. So right now it has a transform component, and then it has these mesh components which give it its visuals. Even though this looks like a block, there's no collider though, so we need to add a collider. So we can add component, we can add physics, and let's just do block collider. We'll keep it simple. And then for the moment, it won't be a trigger. We may need to change it to a trigger at a later date. Again, this is very introductory. This is just being able to show you how to spawn the world and have it be destructible. Okay, so we have our block. It has a box collider. We're going to add a script to it, but we don't have to do that yet. We can still modify this once we've turned it into a prefab. So let's just take this from up here, drag it here, and now it's its own prefab. And we can delete the one from the scene. So now what we need an object to spawn this over and over again. So let's create a GM object. And just to be clear, there's nothing special about a GM object. It's just an empty object that you're going to use for the purposes of being a GM. A game manager. So game object, create empty, and we're going to call this GM. There's actually technically a way of using a script that doesn't require a GM object, but a lot of people are comfortable with a GM object because it lets them know directly what's affecting this scene, because the GM object is in this scene, so you know it's affecting it here. So we want this GM object to spawn this block. So what we need is a script. So right click, create C#. Let's call this world build. We click on our GM object. We drag and drop the world build there. And then what we need this GM object to be aware of this block. So if we open up world build, it should open up automatically in Microsoft Visual Studio. You can delete this line and this line. See this double /? That tells you that this is a remark statement. So in other words, it doesn't get executed. It's purely for internal documentation. So what we need this object to be aware of the block. So public transform, capital T, And then we are going to give this a name. Let's just call it G block 00. I try to avoid using the exact same name when you're in the script. You also don't want variables to ever match the name of a script. So you may think that would be unusual for that to happen, but depends on what kind of naming convention you use. Sometimes it happens, so be very careful. You really don't want your variables to match the name of your scripts. So what we're going to do now, let's actually go back to our scene, and you now see that shows up here. Okay, so what we want to take that grass block prefab and put it there. So now the GM object is aware of this and can do things with it. So like can instantiate it. So when I say instantiate, that's what you should think of when you think of the word spawn, like you say an enemy has been spawned or something's been spawned. Well, that is actually the instantiate command. So in the start area, so we want this to happen in its entirety before, before the first frame is completed. So that way when the first frame gets drawn to the screen, this has all been calculated and done. We want to instantiate. And the instantiate command has 3 arguments. What gets instantiated? Well, we want to instantiate that block. Where does it get instantiated? We are going to put a constant in here for a moment, and then we are going to change it. So new vector 3, we'll say 0, 0, 0. And this is the x, y, and z coordinates. So first argument, what is being instantiated? Comma. Second argument, where is it being instantiated? And then the rotation of the object, well, we'll use the object's own default rotation. So gblock dot rotation. And if I did not make any errors, that should make a single block appear at the screen at 0, 0, 0. However, our camera at the moment is at 0, 0, 0, so we're just going to move it back. And just so you can see what I'm doing, when you click on the object, when you click on the camera, you can see that you have the arrows to move it along the 3 axes. So we'll just kind of get a better perspective. And now let's run that. And there's a block, obviously way too close to it. So what we can do, move that, and let's rotate it down a little bit more. There we go. We'll move it a little bit higher though, and down a little bit more. Okay, so now what we're going to do, we don't want it to instantiate in just one area, but as you can see, that is working. We have now spawned a single block. What we're going to do, we're going to use a loop, replace these constants with variables, and then with just those 2 or 3 lines of code, this will go from spawning a single block to hundreds, if not thousands, depending on how you write the loop. So, for loop, and for those of you who've been coding for years, we used to call these for next, but you don't need to use the word next anymore. So let's go ahead and declare the variable. It is going to be a float type, and let's give it a name that indicates what it's going to be used for. It's going to be used for the x coordinates, so the x position, and we need to give it a starting value. We're going to make it -24, completely arbitrary. And then semicolon. So that separates. The semicolon is used to separate the sections of the for loop. So we've declared what the variable name is, what kind of variable it is, and its starting value. We now have to say under what condition do we want this loop to continue to operate. Well, we're going to say less than +24. Again, fairly arbitrary, semicolon. And then the third, we're going to indicate what happens if it's not greater than 20, or if it's still less than 24 to keep the verbiage the same. If it's still less than 24, when this loops, what do we want to happen? Well, we want XPOS to be increased by 4. Now that's not arbitrary. and then we just need to surround everything with curly brackets. Okay, so the reason why this isn't arbitrary is because, as it turns out, the magical voxel blocks that I made by default take up exactly 4 unity units in each direction. So that's what you're doing. You're increasing the x position by 1 unity unit. So because my magical voxel blocks are actually 40 blocks in each direction, because if you haven't used it, magical voxel makes the shapes that you're making out of small blocks. So it's 40 by 40 by 40. So for every 10 blocks, that's 1 unity unit. If you don't use magical voxel, then this will be different for you. Okay, so we now have a loop, but it would just keep droning in the same place. So we need to indicate that that variable is going to change. So that should work. But I don't want to waste anyone's time, so what we're going to do is we're going to put a loop inside of a loop. We're going to copy this even though we have to change most of it. So this is basically a nested loop because one loop will be whoops, sorry, that's completely wrong. I was just trying to make another squiggly bracket. So this one is going to be the Z position. So we're going to add depth. And it's going to start at 0. That's what we're using right now. And we'll use, let's use that positive 24. It only makes it 6 deep. So let's make it like, let's make it 40. We don't want it to go as far as the eye can see. You want some cutoff eventually. And then again, this will indeed use the increment of 4 because it's a square block. It's 4 units in each direction. So basically, I took this and I just changed every X position to Z position, and I also changed some of the start and end values. But it's the same. You're declaring a new variable, so you're saying what type of variable it is, what's its name going to be, what's its starting value, what's the condition for this to continue, and then what do you want to happen every time this loops. And now we just take that and we put it here. And if I have not forgotten anything, that should now create several rows of from negative 24 to positive 24. And it's going to go from 0 to positive 40, so out away from the camera. So if I haven't forgotten anything, that should make this nice little flat surface. And there we go. So just like that, you've now created the beginning of your world. So it depends how big you want this to be and how many different blocks you want there to be. But you can see, hopefully at this point, to make the rest of the world, that's just rinse and repeat. You would create more blocks, list of those blocks, and then you'd create the loops to place those blocks in certain positions. Now, in this case, we place things adjacent to each other. So it's a little bit harder when things are just kind of spawning wherever. So you might have to come up with more complex calculations than just a simple linear increment. And just like that, we've gotten through half of what we wanted to do. We wanted to have an environment that could be created with just a few lines of code, and we've done it. Now we want those to be destructible. So we need a second script, and we're going to attach it to the block. But before we do that, let's go ahead and make the rest of our blocks, into prefabs. So we're going to take this one, drag it into the scene, and again, we're going to unpack prefab, drag that off, delete that, and then rename this block grass 01. I didn't mean to zoom in like that, but I double clicked on it. But it's useful to see what I did was I started to dig into the top of the block. So in a game like Minecraft, you usually see cracks show up on the blocks. I kind of wanted to take a different approach and actually have the block being deformed. Technically, it's not deformed because it's just using a different model, but it creates the illusion of deformity because what happens, one block gets replaced with another. So we're going to add the same components. We're going to go to Physics, Box Collider. We said we're going to leave it as not a trigger. I'm going to put that into the scene, delete the one from here. Rinse and repeat with block grass 02. Again, you can see this is dug in more. Now you're seeing the dirt. We're going to unpack prefab, drag the default away, delete that unnecessary parent, and then we're going to name this. This one is block grass 02. Rinse and repeat. Add component. Physics. Box collider. Don't make any changes. Drag it into the asset area. Turns it into a prefab. Delete. Last one. We'll probably do this other block in a second tutorial when we talk about building, because this is just about making destructible environment. So spawn the environment, make it destructible. Building is a different kettle of fish. So last one we'll put into the scene. You can see that I made the point of making it even darker. So unpack, drag that off, delete, call this block grass 03. Rinse and repeat. Add component, physics, box collider, make no other changes, drag and drop into the asset area, delete. Now, once you start getting more assets, you'll probably want to create folders. You'd probably want to keep the models in their own folder and the prefabs in their own folder so you don't get them confused. Okay, so now we want to be able to click on a block and have it be damaged and then destroyed. So what we're going to do, we're going to take the first one, block grass. Actually, let's go ahead and make a script. Right click, create C#, and we'll call this block con, so it's going to control the blocks. Going to open that up. Again, you can delete this and this because they're non-executed remark statements. And we're going to just put up here public transform. We'll just call this next block because it's going to vary depending on which block this is attached to. So every object we attach this script to will now be able to link to another object. So let's click on this one. Can we do multiple select with control click? Yes, we can. So we're going to select all four and we're going to drag, whoops, sorry, that is the wrong script. I'm going to drag the block con script onto it. And now if you click on these individually, you'll see each one has the script attached to it. All right. So here's how this works. The next block should be just that. So for the first block, the next block should be 01. For 01, the next block should be 02. For 02, the next block should be 03, because you're doing exactly what the name suggests. You want to be able to replace this block with the next one. So if we click on block 00, we can drag grass block 01. If we click grass block 01, we should go to grass block 02. If we click grass block 02, we're going to go to grass block 03. Eventually, we'll put in coding because what we're about to do will create an error, but will work. Because with grass block 3, there is no new block. At that point, we want the block to self-destruct. So we've added the blocks. Now what we're going to do, we're going to add a new section. It's going to be on mouse down. Because for the moment, we're just going to use a mouse click. And we're going to do two things. We're going to instantiate next block. So what gets instantiated is the first argument, where it's going to be instantiated, transform.position. So what's transform.position? Transform.position has the value of the position of the object the script is attached to. Well, the script is attached to several different objects. So what this is saying is, but the objects that it's currently attached to are the blocks. So whatever the position of the block is, instantiate the next block in exactly the same position, and that's what creates the illusion. One block gets deleted and gets replaced with another block. And then it's going to be next block dot rotation. I didn't do any kind of rotation to them when I made them, so that should work. So again, the same three arguments: what is being instantiated, where it's being instantiated, and the rotation of the object being instantiated. And now we want to destroy the current block. So destroy game object destroys the object the script is attached to. It's attached to all the blocks. So whichever block you just clicked on, it'll get destroyed. So I'm not sure if this is going to work for the final block. We'll see really quickly if it does. But it will work for all the other blocks. So if I haven't forgotten anything, this should work. So there's our block. We're now going to click, and there you go. Well, if we do that one, what about that one? That one. That one. So again, with just a couple lines of code, you have now taken a static environment that you can't interact with to one that can be interacted with. Yes, it won't delete the last one because of the error, so we'll have to put in a line of code. So let's do that, and then I think that will be it for this tutorial, because now you know how to instantiate an entire world and how to make it destructible. So the core functionality is easy to do. It's just all the extra stuff, like all the crafting and the materials and the mobs and the AI. So this series could potentially be very, very long if you want it to be, but we'll see. I kind of want to get you to at least the basics, but so far we've done that. So let's now just do one more thing. So for this block, let's give it a tag. So we're going to go to add tag, list is empty. We're going to type, let's call this last block. We save. And then what we're going to do is back for our block conscript. What we're going to do is, rather than just saying if the mouse is clicked on the block, do this period, we're now going to add a condition. We're going to say if game object, I think we can just do tag, if game object dot tag is equal to last block, I believe I just called it. Oh, that reminds me. Creating the tag doesn't actually apply it. See, it still says untag. So add a tag isn't adding a tag to the object. Add a tag is just creating a whole new tag. You then have to actually assign it. I always forget to do that. It'd been easy enough to edit that out, but sometimes it's good to show you my mistakes. So last block. So what this says is when we click on the block, it's going to check to see what the tag is. So actually, we want this to be not last block. So yes, an exclamation point. So if the tag is not last block, then go ahead and instantiate a block. The only time that this would not be equal to last block is if it's equal to last block, and then in that case, this won't execute. It'll check, but it won't do this, and instead it'll just destroy the object. And I think that will wrap up this video. There you go. You now have the ability to instantiate an enormous and destructible environment. Now, there's certain things you can do to make that look better. So, for instance, we can add a particle system. So that way, when you click on it, there's like a puff of dirt, that kind of thing. Or if it's maybe stone, there's sparks. Again, this is just meant to be introduction. You can't do everything in one video. Games are made over years and years and years. So this gives you the basics. This gives you a destructible environment. And then going from here, we'll decide what the next video should be, because there's so many things. Right now, you destroy the blocks, but you don't get anything. So maybe we should look at what resources you should get. Okay. And right now you have a static position. You need to actually have a first or third person position where you can walk around and click on things. So I think that should do it for this video. I hope you found this helpful. Please leave any comments of features you want to see. Like I said, I already mentioned a couple. The idea of getting resources when you destroy a block, as well as the ability to actually move around the area. As far as making the area bigger, that's just going back into WorldCon and increasing these ranges. Okay, so hope you found this helpful, and please enjoy the rest of your day.